This resource is the second in a four-part series on factoring polynomials. Part 1 considers the greatest common factor. The GCF is defined. We present a method for factoring the GCF out of a polynomial and provide examples. Part 2 considers factoring a trinomial into a product of two binomials when the coefficient of the x squared term is 1. We present the general process and look at multiple examples. Part 3 considers certain special cases. Those cases are defined, then examples are provided. Part 4 looks at factoring a trinomial into a product of two binomials when the coefficient of the x squared term is not 1. We look at the general process, then multiple examples. Before we consider factoring, we need to determine exactly to which type of polynomial this factoring method applies. We will use this method to factor a quadratic trinomial. Quadratic means that the highest power is squared, and trinomial means there are three terms in the polynomial. The standard form for this type of polynomial is ax squared plus bx plus c, although those plus signs may also be minus signs. Depending on the values for a, b, and c, we may be able to factor a quadratic trinomial into the product of two binomials. In effect, we are unfoiling the polynomial. We know the answer we got using the FOIL or equivalent method. We want to know what was in the two sets of parentheses that we multiplied. This resource will only consider the case where the a, the coefficient of the squared term, is 1. We will consider instances where a is not 1 in a later part of the factoring series. To start, we split the first term, the x squared, into two separate x's and place them one each in two sets of parentheses. Next, we look at the last sign in the polynomial. If the sign is a minus, you put a plus in one parenthesis and a minus in the other. If the sign in the polynomial is a plus, that means the sign in the parentheses should be the same. The signs in the parentheses will both be whatever the first sign of the original polynomial was. Now we will factor the last term, the constant. What pairs of numbers multiply together to give that number? Then we attempt to match to the coefficient of the middle term. We do the same operation as the last sign of the original polynomial. Once you have matched the b, we fill in the parentheses. The larger factor goes in the set of parentheses whose sign matches the first sign from the original polynomial. To check your answer, you can always multiply the parentheses together. If you did your factoring correctly, you should get the original polynomial as an answer. Let's look at some examples. In our first example, suppose we want to factor x squared plus 8x minus 20. We split the x squared into x and put them into parentheses. Now we look at the sign at the end. We see a minus 20. So inside the parentheses, we put a plus and a minus. Next, we want to factor the number at the end. We can get 20 if we multiply 4 by 5, 10 by 2, or 20 by 1. We begin the process of trying to match the 8 that is in the middle term. Because we have a minus 20 at the end, we subtract the factor pairs. First we try 5 minus 4, which equals 1. Since that is not the 8 we are looking for, we know the correct factors are not 5 and 4. We try the next pair. 10 minus 2 gives us the 8 we want, so we have found our answer. Because we had a plus 8 in the original equation, we want to put the larger factor in the parentheses with a plus sign. So when we factor x squared plus 8x minus 20, we get x plus 10 times x minus 2. Let's look at some more examples. Suppose we wanted to factor x squared plus 8x plus 12. Again, we start by splitting the x squared. In this example, we have a plus as the last sign in the polynomial. This means that the signs in our parentheses will be the same. Since we have a plus 8x, we will have plus signs in both parentheses. We factor the 12 at the end. 12 could be 3 times 4, 6 times 2, or 12 times 1. Because our factor had a plus at the end, we will add our factor pairs to match to the 8 that is the coefficient of the x term. Adding 3 and 4, we get 7. That pair of factors did not work. We try the next pair of factors. 6 plus 2 does equal 8, so this pair works. Because the signs in the parentheses are the same, the order we insert our factors does not matter. So when we factor x squared plus 8x plus 20, we get x plus 6 times x plus 2. Let's look at another example. Suppose we want to factor x squared minus 7x minus 18. Split the x squared. The minus 18 at the end means we put a plus and a minus in the parentheses. Factor the 18. Our options are 6 and 3, 9 and 2, or 18 and 1. Because we had a minus 18, we subtract the factors to try to match the 7. 6 minus 3 is 3, so that pair is out. 9 minus 2 gives us the desired 7. Because we had a minus 7, the larger factor goes in the parentheses with the minus sign. So factoring x squared minus 7x minus 18 gives us x plus 2 times x minus 9. Let's see one last example. Let's try to factor x squared minus 11x plus 24. Split the x squared. Because we have plus 24, our signs in the parentheses will be the same. Since we have minus 11x, both signs will be minuses. We factored the 24. We could have 6 times 4, 8 times 3, 12 times 2, or 24 times 1. Because the problem had plus 24, we add the factor pairs. 6 plus 4 equals 10, but we were looking for 11. 8 plus 3 gives us the 11 we want. Since we have minus signs in both parentheses, the order we insert the factors does not matter. So when we factor x squared minus 11x plus 24, we get x minus 8 times x minus 3. To unfoil a polynomial, it needs to be in standard form, ax squared plus bx plus c. If the coefficient of the x squared term is 1, or if you do not see a visible coefficient, then we can use the following process to factor the polynomial. First, you split the x squared into x, and place the x's, one each, in sets of parentheses. Next, you inspect the last sign of your polynomial. If it is a minus sign, you can automatically put a plus in one of your sets of parentheses and a minus in the other set. If the last sign was a plus, both parentheses get the same sign as in front of the b, the coefficient of the plane x. Then you factor the constant at the end into factor pairs. Try to match to the b using the same operation as the last sign of the original polynomial. Once you match, put the larger factor in the parentheses with the same sign as in front of b. Some polynomials fit special formats. and are slightly easier to factor. We will explore them in the next part of this factoring series. Stay tuned.